Valid palindrome. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. So on its face, it looks pretty straightforward. The real trick is just like dealing with strings and stupid edge cases. Honestly, I find this problem a little bit frustrating, but we're learning it for a reason. And the reason is dealing with strings and knowing a couple of functions. So I'll start off with, first of all, it's the general approach is going to be you want to know if it's the same forwards and backwards. So we can use a two-pointer approach. You start at one end and you start at the other end and you continuously compare, and you can either have go like outside in, which is probably the easiest, and compare character by character, or you can start at the middle and then go outside from there character by character. Either way, it's going to be linear time and one space because you use the two pointers. You may be tempted to use a stack. Don't do that. Puts you at linear space. Use two pointers. That's the way to go. So the functions I'm going to talk about are standard library functions. They're part of the, I don't remember if they're C functions. They might be C functions, but they're definitely in C++ as well. One of them is, there's is alpha. There's is, I think it's is number. It's either is number or is numeric. And then the last one is alnum. These are all standard library functions. And these are, I guess they're worth memorizing. Certainly is alpha. They don't come up super often, but they come up often enough, I guess. Pretty much any language has functions like this. This alnum in particular is the one we're going to end up using. And it's, yeah, it just returns a boolean. And the other one that we're going to know is to lower. Just like that. Yeah, so we're going to end up using these two functions, and that's going to be the core of our solution. You could also get into knowing some stuff about how ASCII letters are encoded, or UTF-8. So ASCII is a subset of UTF-8. It's the original subset. And there's some number ranges. I know in the ASCII like numbering scheme, you represent characters as numbers because everything's a bit, bits, strings, groups of bits. And particular numbers are interpreted as particular letters, and the lowercase letters are all clumped together in sequence. So A and then B and then C in like increasing numeric order. And then after them comes the uppercase letters. So you could just like know those and convert based on that way. That's something to mention to your interviewer and just say like, hey, do you want me to deal with ASCII characters, or is it okay if I just use these standard library functions? Hopefully, they don't want you to know like ASCII numbering, because that's not the kind of thing you should ever have to have memorized. That's something that like you pull up a table. Because even when people do like, if you want to see like relative like spacing, what they'll usually do is they'll subtract something like z minus a, something like that, and that gives you like I think 25 or 24. It's either, I think it's 24. No, it's 25. It's 25. Because if A is not 0, but Z is 25 higher than A, something like that. That happens a lot where you'll do like character arithmetic. But I think it's above and beyond if you actually know what the value of like A is. I don't. Does it tell me on tooltips? It sure doesn't. Anyway, so let's start writing it out. So we're going to do a for loop, and I'm going to get a little fancy with the syntax. I'm going to declare multiple variables. So for int, I guess I'll do a, and then b is. So if you're not as intimately familiar with C style like for loop syntax, the first block, the first statement It's literally just a first statement. It's an initializer. It runs at the beginning of the loop. You can declare multiple variables if you want to, as long as you're doing one statement. I kind of, now that I'm saying that, I wonder if you can do something in like inside curly braces and have like something really crazy. That might be like kind of hard to read and certainly maybe a little too much more than you ever want to do, but it might be an option. And then the second statement is the conditional that runs on every step of the loop. So while basically a for loop is a superset of a while loop. So the second statement is the while condition. So while a is less than or equal to b, I'm going to go from outside in. And the last statement runs at the end of every iteration of the loop after the contents of the loop have finished. So you could leave it blank and just do checks on the inside of the loop. And that's actually what I'm going to end up doing. And the reason for that is because of the dang finickiness of like these edge cases and dealing with like non-alphanumeric characters and having to like increment the pointers, or not the pointers, the indices a little bit, based on, okay, are we skipping this and that sort of thing. I'll start writing it out. So if not is, or yeah, if is is not numeric, is alphanumeric, ALNUM. If the first character is not alphanumeric, we're going to skip it. And the reason I'm doing this is the whole reason I'm not putting like a third statement there, because I'm doing it here. Okay, what I'm doing is, suppose there's multiple non-alphanumeric characters in a row, like here, this bit here. Suppose we're looking at these two. Well, we want to skip them both, but we also want to still check this conditional between each of those steps in case we get to the end of the string, or if we surpass the right pointer or something like that. If we're checking for the exit condition. And that's why I'm doing if and continue instead of a while. So I can still check the exit condition. You could also check it separately and then do a break. I think this ends up being like a little bit cleaner, even if it's not as like simple to come up with in the first place. And then same thing for the right side pointer. So if not is al num s b, and then we decrement that and continue. All right, so if there's multiple, whatever non-alphanumeric characters, it'll skip all of them, and then it'll go, check the exit condition each time. And then once this is squared away, it'll check these, and it'll do this repeatedly, check the exit condition each time. It'll see this. This won't execute because we were not going to get past it until it's, not true. And then once we get past both of these, we're looking at 2 alphanumeric characters. And the last thing we want to do is convert letters to lowercase. So there's a couple ways we could do it. We could override the string. What I'm going to do is I'm just going to do it in the conditional. So if to lower s on the left side, and then if that's not equal to lower s on the right side. So this is our false condition. And yeah, the reason I'm doing an exit condition here instead of like, actually, no, I take that back. You have to check the whole string to know if it's a palindrome. So it makes sense to have like return true at the very end of it. And then at any point and before then, if it's not true, if they're different, then you're gonna immediately return false and just skip the rest of it. That doesn't change the theoretical runtime, but it does change the real runtime. So you shave off a few, I don't know, nanoseconds, or it depends on the inputs. The last thing we need to do is move both indices at the same time if we don't exit. So what I'm gonna do is I don't know. You could do them on another line, or you could do them here, and then specifically post increment and post decrement, so that we check these conditionals before actually changing the values. And I think that'll pretty much do it. So I guess I'll write out the runtime, time and space complexity, and then do an example. O of n, time, and O of 1 space. Like we said, the time is this for loop. The A is only ever moving to the right, and the B is only ever moving to the left. And we're going to move something, either one or both, on every iteration of this loop. So that's why we have the max runtime of linear, and then in any of these in particular steps, we're just doing constant. So that's the comparisons constant. Technically, operations are linear on the number of bits, but we're only dealing with 32-bit numbers here, integers specifically. So it's a constant number of bits. Technically speaking, this int it doesn't necessarily mean 32 bits. It's whatever the machine specifies. But whatever it is, it's constant for the machine, so it's a constant runtime. Okay, so we've got the time and space. Let's do the example. I'm gonna do, yeah, I guess I'll just do the long one, and then I'll skip this and then call it good. All right. So start off our pointers. Yep, I'll do the star. All right. So starting off, initialize our pointers. One on the left, one on the right. We've got our condition. So we've got this if is alphanumeric, and it is, so we're negating, so we're not going to do that. And then same on this right. So skip both of these. A is we're not replacing the values in the input string, but I'm gonna change them just for comparison. So we have A and A. Cool. So that means we move them both. All right, next one, we move them both, and then we're looking at this left. It is not alphanumeric, so we're incrementing it. And then now it is alphanumeric, so then we're on to B. That's we're not entering this part, so now we're comparing M, and we got M. Cool. Yep, that's true. So then we're gonna move both pointers. And then a similar deal. None of these happen. Now we're comparing A, and then we move both pointers. Or yeah, keep that on the right, on the outside. All right, next iteration, they're both alphanumeric, so now we're comparing N and N. Cool, move that, move that. Okay, so now we're hitting this condition, comma is not alphanumeric, so we are incrementing A, and then checking the, continue, so check the loop again. No extra condition, it's not alphanumeric again, so we're gonna increment again, continue, and then check, okay, cool. Now we're comparing A, we're down to here, A and A. Those the match, so increment, move both pointers. Okay, next iteration, again, it's not alphanumeric, so we skip it. And then, okay, next iteration, we're comparing P and P, but we're doing the two lower, so that means we're actually comparing that. We're not changing the input again, but we're comparing lower cases. Okay, and those both match, so we're gonna move the pointers. Next iteration, that's not gonna trigger, but this is, because we're looking at a space. Move that, and then again, well, next iteration of the loop, we hit the same deal. So now we're comparing L and L, those match, so we move the pointers, da-da-da. And then I'll just keep stepping through it, I guess. I'm not gonna keep repeating the discussion as much. So yeah, A and A. Now we're at N and N. this again, A and A. This is not alphanumeric, so move again. Now we're at C and C. It's the same character, so then we move that there and that there. And now we have our exit condition. The low pointer is higher than the high pointer, so we've got that, meaning we hit this case, and then we return true. And then, do I want to do the non one? I'll speed through this false example here. I'll try and jump through it quickly. All right, so we start off with our pointers, and then we got R and R. Then we have A and A. Now we have C and C on alphanumeric, so move that. Oops. Now we have C and A. Those are not going to be true. So this is, we're going to hit this, and then we're going to return false. All right, that's what we wanted. I'm going to go ahead and give it a run. Boom. Nice. Submit. And then mark it off. Thanks, guys.